Hi, I'd like to show you a little interesting coastal sediment transport case. This is Cartagena de Indias in Colombia, South America. You see here the turbulence in the water. We see now from the southwestern end of Boca Grande in Cartagena. Notice how the water has different colors, with plumes of higher sediment concentration going out and then clearer water outside. The clearer water is coming from the southwest, the Darien current. And if we look here over towards the island Bomba, you'll see that there is no transport going past this groin. So this is the end of the coastal cell of sediment transport that's coming from far away from the mouth of the Magdalena River, apparently, by Barranquilla, the next big town along the coast. As you can see, there are groins constructed here for coastal protection, and there's also some coastal hardening in the right end of the picture below the tall hotel there. And there is no sand left, so hardening the shore like this increases the wave energy close to the coast, and it can actually lead to increased erosion, because obviously this is the whole peninsula here is sand. And let's go now, you look at the bay, the colors in the water, and now we'll go to the other end of this bay and look from the opposite direction. This is the headland where the sand transport is going around, and you can see that close to the shore. There is like maybe 30 meters wide zone of higher sediment concentration, where the suspended sediment is up in the surface. At the horizon, you see the coast barely visible in the haze from where the sediment transport is coming. And out in the sea here, what we're looking at, the current near the coast is going towards us. A little bit further out it's going in the opposite direction. That's the Darien current. And then even further out, it's again going towards the southwest, the general circulation in the Caribbean, this part of the Caribbean. Current measurements in this part of the coast have shown that the circulation is quite complex here in this area we are viewing, with different directions, sometimes in the surface and at depth. And this complexity is what we see in the color of the sea here, where water bodies, water cells, units with different level of sediment concentration are mixing. And to some extent, these colors can also reflect the bottom, but to know that, we would have to go out and look in the water, look at the bottom. This area here definitely should be investigated for what the sediment dynamics are, because this is a beach with erosion problems. There's inundation problems here now. And the question is, what is happening with the sand that's coming here? It's an area where I definitely would recommend both investigation with side-scan sonar and so on, of course, but also to put out sedimeter instruments and perhaps also seditrans instrument to measure the sediment dynamics on the bottom and in the water, to see how the sediment and how the water is moving on the bottom and in suspension. These groins represent an earlier attempt to get sand to accumulate along this shoreline. Now there is a new project that's in the phase of being well, they're actually in the solicitation phase now, to further strengthen this coast. But my recommendation is to study the sediment dynamics, and I strongly suggest measuring what is happening with the sand on the continental platform here, out to the slope, and to see what is happening with these colors we see in the water. What is actually happening with the sediment on the bottom and in the water? Because only knowing what the dynamics are can you really decide how you best preserve the coastline in the long run without having to constantly redo sand replenishment, for instance. In Lindrum Incorporated, lindrum.com and sedimeter.com on internet, we have instruments for measuring the sediment transport in the sea. And we also have the Nilsson suspended sediment sampler, which can be used to measure the fluvial transport of sediments to the sea and to the coast.